Hey there, in this video we're going to cover section 12.1, sequences and summation notation. So first of all, what is a sequence? So a sequence is a function whose domain is a set of natural numbers. The terms of the sequence are the function values. So we usually say a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on. It goes on to infinity because the natural numbers go on to infinity. So we call the function a sub n, where n is a natural number, and a sub n is also called the nth term of the sequence. So just a reminder, the set of natural numbers is essentially the counting numbers 1, 2, 3, 4, 5, 6, all the way to infinity. So let's try our first example. So this is a sequence, so we're given the nth term of the sequence, or also the function. So this means it's going to take a natural number and then it's going to add 1 and divide it by the natural number squared. So it says list the first 4 terms of the sequence. So we're going to say then a sub 1, right? It always starts with the natural number, so all sequences start with 1. So this is going to be 1 plus 1 over 1 squared, which is 2 over 1, which is just 2. So I'm going to go over here and say a sub 1 is 2. A sub 2, this means that n is equal to 2. So we're going to say this is n plus 1 over n squared, so 2 plus 1 over 2 squared. So we get 3/4. So a2 is 3/4, and a3 means now n is equal to 3, so we're going to say 3 plus 1 over 3 squared, right? N plus 1 over n squared, and so I get, what's that, 3/9, and I can reduce to, oops, that's not 3/9, that's 4/9. 3 plus 1 is usually 4. So we can say a sub 3 is 4/9. And then the last one, when n is 4. So we're going to get a sub 4 when n is 4, so 4 plus 1 over 4 squared. So we get 5 over 16. So I can say a sub 4 is 5 over 16. And so those are the first 4 terms of this sequence. So the sequence is the function that assigns essentially a formula to every natural number. And so to write the sequence, I will say then a sub n equals n plus 1 over n squared is equal to the set of, and then we start with our terms. So it'll be 2 3/4, 4/9, 5/16, and so on. It goes on to infinity. So if you wanted to find a sub 21, for example, so this means n is 21, so you would substitute it into the formula. So a sub 21 will be 21 plus 1 over 21 squared. And so whatever that would be, 22 over 21 squared. Okay, so our next example, let a sub n be, and I have a negative 1 to the n here, times the quantity n over 3 to the n, and that's a comma. List the first 4 terms of the sequence. So same thing. So we're going to go a sub 1. That means when n is 1. So everywhere I see an n, we're going to put in 1. So we minus 1 to the 1 times 1 over 3 to the 1, which I'm just going to get negative 1/3. So a sub 1 is negative 1/3. A sub 2 is, again, we replace the n with 2. So we minus 1 squared, which will be positive, times 2 over 3 squared. So that will become a positive, right? Negative 1 squared is positive, 2/9. So a sub 2 is 2/9. A sub 3 is, replace the n with 3, so minus 1 cubed times 3 over 3 squared, or 3 cubed. N is 3. So now a negative 1 to an odd power stays negative, so I'm going to have negative 3 over 3 cubed is 27. And this one I can reduce. So 3 goes into 27 9 times, so I get negative 1/9. So a sub 3 is negative 1 9. So notice how it's then alternating. So this is what's called an alternating sequence. And so lastly, when a is 4, so when a is 4, that means n is 4. So negative 1 to the 4th times 4 over 3 to the 4th. So a negative 1 to an even power becomes positive. So I'm going to have a positive 1 times 4 over 3 to the 4th is 81, right? It's essentially 27 times 3, which is 81. So I get a sub 4 is 4 over 81. And so those are the first 4 terms of our sequence. So we can say then that a sub n equal to negative 1 to the n times n over 3 to the power of n is the set of terms. What was the first term? We had negative 1/3, 2/9, negative 1/9, and positive 4 over 81, and so on. So this is an example of something that's called an alternating sequence, because the sign, it alternates from positive to negative. So that's why it's called an alternating sequence. So let's try examples in reverse. So finding the nth term of a sequence. So what if you're given a list of the terms already? So in this case, you're given how many terms are here? 1, 2, 3, 4, 5. You're given 5 terms, and you're asked to find the nth term. So the formula for a sub n. So when you see something like this that says find the nth term of a sequence, what that really means is find a formula for a sub n. Just like you were given up here, we were given the formula, right? So the nth term is the formula. So in both of these, we're given the formula, and we were asked to find terms of the sequence. Now we're given the terms of the sequence, and we're asked to find the formula. So find the nth term. So how do we do that? Well, so look at 6, 11. So one of the things I want you to think about is, can you guess the next term? So it goes 6, 11, 16, 21, 26. Can you guess what the next term is? So is there a pattern? And one of the things that I notice is that to get from 6 to 11, what are we doing? Looks like there's a changing by 5. So you added 5. And from 11 to 16, you add 5 again. From 16 to 21, we add 5 again. From 21 to 26, you're adding 5 again. So it makes sense that then for the next one, if we add 5 again, you're going to get 31. And then add 5 again, you're going to get 36, and so on. So this is going to go on forever. So you're adding 5. So there's a change of 5 in every term. So it's a change of 5, right? So that's kind of like slope. So my a sub n is going to be 5n. And then what do I need to do to get 6 when n is 1? So when n is equal to 1, a sub 1 is 6. So I need to add or subtract something to get to 6. So it looks like if I add 1, does that work? Right, so let's try it. So when n is 1, using this formula, a sub 1 will be 5 times 1 plus 1, which is in fact 6. So now let's try it with the fourth term. So 1, 2, 3, 4. So 21 is here, a sub 4. So I'm going to say 21 equals a sub 4, which according to our guess for the formula, it will be 5 times n. So 5 times 4 plus 1, which is 20 plus 1, which is in fact 21. So it seems to check. So then I can say with confidence that my a sub n is 5n plus 1. Now, one of the things that I want you to notice is that when I say find the nth term of a sub n of the sequence, and I said this can also mean find a formula for a sub n. So this is just one that we came up, but you could find other formulas that still represent the same sequence. So they might look a little different, but they still represent the same sequence. So let me see up here. Notice for the first example that we did, if you were given these terms and asked to find a sequence, one of the things that I will do is I will say, well, they all have a denominator except for the first one, so I'm going to put a 1 under there. And it's almost like you have two sequences. You have the numerator, and I see that, oh, it's changing by 1. So when n is 1, how do I get my next one? Well, it's n plus 1, so that gives me that one. So when you have a numerator and a denominator, when you have fractions, it's almost like you have two sequences, the numerator one and the denominator one. And now here, notice that I'm squaring the n. That's 1 squared, that's 2 squared, that's 3 squared, that's 4 squared, and so on. So that's another way that you can, given the terms, go back to the original. This one might be a little bit harder to see, especially with that -1/9 because it reduced, right? Remember the -1/9 came from doing 3 over 27. So this one might be a little bit harder to see. If we had left it 3, notice that it goes 1, 2, 3, 4, and the next one will be 5 over 243. So, but because that one was reduced, it makes it a little bit harder to see if we were given the terms of this sequence and asked to go back to the formula. Okay, so this is an example that has a numerator and a denominator, but the numerator is all 1. So then I know that my a sub n is going to have a 1 in the numerator. And what's happening here? So I have powers of 2, looks like 2, 4, 8, 16, 32. Right, that's if I have 2 to the n, then when n is 1, I have 2 to the 1. When n is 2, 2 squared, and so on. So this will appear to be powers of 2, but notice that it's also alternating. So this is positive, that's negative, and then you have positive, that's negative, positive. The next one is probably going to be a -1 over 64, just based on this pattern. So that means I'm going to have a -1 to the something here. Now the first one is positive, not negative. So it can't just be n, because remember, n starts at 1 for sequences. So if I just put n, -1 to the 1 is going to be -1, but my first term is positive. So I'm going to do n plus 1. So that when n is 1, I get -1 squared, which will make that positive. And then I have times 1 over, that appears to be just 2 to the n. So I can write it as then a sub n is equal to -1 to the n plus 1 over 2 to the n. That's an exponent, 2 to the power of n. Try to make it clear that it's an exponent. Okay, and then just check it. So when n is 1, do we get positive 1/2? So a sub 1 will be -1 to the 1 plus 1 over 2 to the 1. Yes, we do get positive 1/2. When n is, let's see, 1, 2, 3, 4. Let's try when n is 4. So a sub 4, we should get -1/16. So let's see, what do we get? So it'll be -1 to the 4 plus 1 over 2 to the 4th. So 4 plus 1 is 5, which is an odd number, and -1 to the 5th stays -1 over 2 to the 4th, which is 16. So yep, -1 over 16, so that checks. So it looks like our formula here is correct. Now, if this wasn't a 1, so if it went like 1, 2, 3, 4, 5, or 4, 8, 12, then you have a different sequence on the top, and so you will have to find also a pattern for the numerator. Okay, so now what about the other type of sequence that you may see is what's called a recursive sequence. And so recursive sequences are sequences where you're given the first term or any other term in a formula based on a previous term. And I know that sounded super confusing. So let me write out a sequence. So if I have a sub n, for example, it always starts at 1, unless specified. Sometimes you'll be told start with n equals 0 or start with n equals 5. So if you're told specifically where n starts, that's the only time that it won't start at 0. I mean at 1. So you have a sub 1, a sub 2, a sub 3. So these are the terms of the sequence. A sub 5, and it goes on until you get to a sub n, and then it still keeps going. It goes on to infinity. So what is the term before a sub n? So notice that for a sub 5, right, if n was 5, the term before it is a sub 4. If n was 3, I get a sub 3. The term before it is a sub 2. So when I have a sub n, regardless of what n is, the term before it is a sub n minus 1. So that's essentially how a recursive sequence is based on you're given your a sub n term with respect to the previous term. So here, when you see a sub n minus 1, that's the previous term. So here I have a sub 1 is 3. So if I wanted to find a sub 2, according to this formula, right, n is 2. So I'm going to have 2 a sub 2 minus 1 plus 1, which is really 2 a sub 1 plus 1. And I know what a sub 1 is. A sub 1 is 3. So I can substitute that in. So I'm going to have 2 times 3 plus 1, which is 7. And now I can find more terms of the sequence. So a sub 3 then is going to be 2 times a sub 3 minus 1 plus 1, which notice is 3 minus 1 is 2. So it'll be 2a sub 2 plus 1. And we just found here that a sub 2 is 7. So I can put that in here. A sub 2 is 7. So this becomes 2 times 7 plus 1, which is, what's that, 15. So that's my a sub 3. So I'm getting my sequence. So a sub 1 was given to us as 3. A sub 2 is 7. A sub 3, I just found it to be 15. And what about a sub 4? So a sub 4 is 2 times, and now we don't have to necessarily do this, right? 4 minus 1 is 3, so it'll be 2 times a sub 3 plus 1. So 2 times the previous term plus 1. So that's a better way to think about it, or a faster way. Not necessarily better, just a faster way. So then a sub 3, we found it to be 15. So this will be 2 times 15 plus 1, which will be 31. And so on. So this is one way to write the sequence. Now that I have the terms of the sequence, I could probably find a different way to write it. Right? Is there a common difference from 3 to 7? The difference here is I'm adding, oops, where did my screen go? I'm adding 4. And what about from 7 to 15? So this, we're adding 4 here. To get from 7 to 15, we add 8. To get from 15 to 31, we're adding 16. So these are, notice that these are powers of 8. So what do you guess we're going to add to the next one? So 4, 8, 16, the next power of 2 is 32. So just based on this, if I add 32 to 31, what do I get? I should get 63. So let's check it. So a sub 5 will be 2 times the previous one, right? 2 times a sub 4 plus 1. So it'll be 2 times 31 plus 1. So 2 times 31 is 62, plus 1 is 63. So that checks. So the fact that the difference is increasing by powers of 2 leads me to believe that this a sub n is going to be 2 to the n, and then plus or minus something to make it, so our first term was 3. So 2 to the 1 So this might not work. So this may be a little bit harder to come up with a pattern because at first I'm thinking I want to make it 1, but then notice that when I use 2, it doesn't work because 2 squared is 4 plus 1 is 5, not 7. 2 cubed is 8 plus 1 is 9, not 15. So this isn't quite working. But the formula for this, another formula, does have something to do with powers of 2. So I encourage you to figure out what that might be. And I'm going to record another video for summation notation.